welcome back to my YouTube channel, Massa Tutorials. Please do go to subscribe to this channel so that whenever I post any video, you'll be the first to receive it. Alright, please let me make a correction here. On our last video, we were treating change of subjects as relations involving fractions. Then I give you assignments on this question. I think question 1 then question 2. I said x equals m plus a all on n minus a. So you have to make what? A on x the subject. You have to make a on x the subject. And also I give you x equals m minus a all on n plus a. You have to make what? X on a the subject. Alright. You can correct it so that replace this one, clean this x, then replace it by m. Then this m. Do it x and here also x. And here also m, x, then x. So that will be a on x, then x on a. That's the correction I want to make. That's the correction here. So the real question is m equals x plus a all on x minus a. You have to make a on x the subject. Then m equals x minus a all on x plus a. You have to make x on a the subject. So that's the corrections. Alright, thank you very much. Alright, today's topic, we are still on change of subject. Alright, so our next subtopic is relation involving squared variable and square root. Relations involving squared variable and square roots. Square roots. Alright, now that's the square root symbol, or that's the square root sign. You can call it the radical sign. Or the square root sign here. Now, let's see some of the root signs. We have square root, we have the third root, or the cube root, we have the fourth root, we have the fifth root, we have the sixth root, then on, and so on and so forth. So we have the square root, the cube root, the fourth root, the fifth root, and the sixth root. It continues as that. Alright, let's proceed. So if you get a question or if you get a relation involving what? Squared variable and square root, how will you answer that? Now, let's see an illustration here or an example here. If I have m squared equals t, m squared equals t. Now, this m is squared. That's the relation. The m is squared. So m squared equals t. Now, we are not am. So we are to make what? M the subject. We are to make m the subject. Since m is squared, you want m but not what? M squared. So we have to what? Take the square roots of what? Both sides of the equation. You have to take the square roots of both sides of the equation. So this one becomes square root of m squared equals the square root of what? T. So now, this square removes what? This square root. It removes the square root. So we have what? M being left alone equals the square root of what? T. So that's correct. So now we've made what? M the subject, not M squared. M the subject of this relation. Now, if you want to test whether your answer is correct, M equals square root of T. You want to make T the subject, because here T is also the subject here. T equals M squared equals T. Yeah, the same. So now we want to make T the subject here. Now, T has what? A square root. T has what? A square root. But we want what? T. So how will we solve this question? So what do? Since here we have what? A square root here. We have to what? Take the square on what? Both sides. We have to what? Square both sides of what? The equation. You have to square both sides of the equation in order for this square root to go away. Or to remove this square root, you have to square both sides of the equation. I've told you that in mathematics, whatever you do to the what? To the left hand side, make sure to do the same thing to the what? Right hand side. Or whatever you do to the right hand side, make sure you do the same thing to the what? Left hand side. So if you want T but not square root of T, then you have to take the square of what? Both sides. So you have to square both sides. So now here it becomes M all squared equals square root of T all squared. So now this square cancels that. So I have T equals what? M squared. So T equals M squared. Now we can see that this one, it carries us back to the what? To the question again. It carries us back to the question again. So this is what we'll be doing. We're just playing with it very, very well. So that's what we'll be doing today. Now if you get cube root, if you get fourth root, that's the same thing. Now let's see. Let's go on and see the cube root and the fourth root. I believe you understand that. Alright. Let's see the fourth root. The fourth root and the fifth root. Let's say I have M cubed equals T. M cubed equals what? T. This time around, M is what? Cubed, right? This time around, M is cubed. So we want M, but not M cubed. So what do? We have to take what? The cube root. You have to take the cube root of both sides of the equation. You have to take the cube root of both sides. So you take the cube root, or we will take what? The cube root of both sides of the equation. So now cube root equals the same thing here, cube root. So now this cube here, 3, cancels the whole of the cube root. So we have what? M equals cube root of what? T. M equals what? Cube root of what? T. Also, if I have M equals cube root of T, then I want to make what? T the subject. I want T to stand on its own. Then I have to what? Remove what? The cube root. I have to take away the cube root. In order for us to take away the cube root, we have to what? Take what? We have to take the cube of what? Both sides. So now, M to the power 3, right? We take cube of what? Both sides equals cube root of T all to the power 3. Then this 3 cancels that. Cancels the cube root. Takes away the cube root. So I have M cubed equals what? T. So it means that therefore T equals what? M what? Cubed. Here therefore M equals what? Cube root of T. So now we can see that this has sent us back to what? The question itself. So that's how we'll be doing today. We've done relation involving fractions, relation involving brackets, relations involving addition and subtraction. When you have a relation involving addition and subtraction, you know what you do. When positive sign crosses the equal sign, or when a positive sign is transposed, you get what? A negative sign. And when a negative sign is transposed, we get what? A positive sign. So when a negative sign crosses the equal sign, it becomes positive. And when a positive sign crosses the equal sign, it becomes negative. So you put that into your memory. Now we have relations involving division. When we are multiplying, I told you that if you want to separate friends in mathematics, we do what? We use our two. If you want to separate numbers, we use these two, or variables. We use the two. That's the division, right? A symbol, division. So you divide both sides of the equation. You divide both sides. Make sure not to send the variable, please. When they are multiplying, you don't send that. No. You divide so that you get the other variable. All right. We did what? Relations involving what? Fractions. I said when you have a relation involving fraction, what do you have to do? LCM. You have to find for the LCM, the least common multiple, or the lowest common multiple. You have to find for the LCM. So when you find for the LCM, you get the number of terms, and you multiply each term by the LCM, so that it will move, or it will take away the denominators or the divisors. Again, when you have a relation involving fraction, you find for the LCM. The LCM. So if you find for the LCM the least common multiples or the lowest common multiples, to take away the denominators, make sure to find for the number of terms in that equation. The number of terms. I told you that in order for us to get the number of terms, make sure to check the operation sign. Has it separated the variables? Because if I have m plus 3, I have two terms here. Because the addition sign has separated m from 3, or 3 from m. So I have two terms in that expression here. Alright. So that's how to solve relation involving fractions. So if you want more of the tutorials, please visit my last video. You get that. Alright, so now let's move on to our subtopic, relations involving squared variable and squared root and square root. But you don't worry, we'll talk about root signs, not only the square root. I'll go further, then do root signs also. Now, so as I was saying, we'll be playing with this. So if you get fourth root, you know how you go about it, and when you get fifth root, you know how you go about it. I'm sure you get only to the cube root, to the cube root. Most of the times, it's only the square root. Most of the times, usually, most of the times. All right. So let's start with an example. So this is what we will be doing. So let's start with example 1. Example 1. If I have E equals MC squared. If I have E equals MC squared, we are to make C, this variable, or the circled variable, the subject. So how we go about this? E equals MC squared. It contains an equal sign, so it becomes an equation. So E equals MC squared. How we make C the subject? First of all, We have two terms here, right? One term and two terms. So let's start. E equals mc squared. Now, you can see that this m is multiplying itself to what? C squared. As you can see, m is multiplied by what? C squared. So when you multiply m by c squared, we get the result mc squared. It's being multiplied because m times c squared gives what? mc squared. Right? So now, if it's being what? Multiplied, then what will we do? I told that when they multiply themselves, if you want the variable, what do you have to do? You have to divide. So now, I have to divide both sides by what? M. This m here. So I have m equals what? M. So this one cancels that. Right. So I have E on m equals c what? Squared. C squared here. Now we want what? C, but not what? C squared. So what do you have to do here? You have to what? Take the square root, as I said earlier on. You have to what? Take the square root of both sides. Do you understand that? For this square, for this 2 to go away. So square root of the whole of this fraction, E on m, equals square root of what? C squared. So this square cancels the whole of that square root. So I have what? Square root of E on m equals c. So therefore, c equals square root of E on m. So that's how to solve what? This equation. How to change the subject of the variable. Very, very simple. So you have to watch the steps I take. And you'll be alright. You'll be fine. It's not difficult. It's just a gradual process. You get it. So just listen to the instructions I'm telling you. So if you listen, then you are cool to go. Alright. So please watch the procedures. Alright, let's move on. Example 2. Example 2. We have g equals 2 pi square root of L on, let's see, A. Yeah. We have to make L the subject. We have to make L the subject. Now this question can be solved in what? 2 folds. Yeah. Can use 2 methods in solving this question. Very, very simple. Very, 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 very simple. Alright. Now let's recall ourselves back to algebraic expression. Yeah. Algebraic expression. Or indices. Yeah. Indices. So if we have a squared, b squared, all squared, a squared, b squared, all squared. Now, with this square here, is affecting a squared and also affecting what? B squared. So I can use the laws of indices as what? A squared all squared times b squared all what? Squared. So this one means what? A to the power 2 times 2 then times in brackets b to the power 2 times 2 and also in brackets. So this one in brackets. So I'll get to a to the power 4 times b to the power 4, right? So I have a4, b4. Now, someone is somewhere saying that you are wrong. I know what you are thinking. Thought I would add these powers. No, because they don't have what? The same what? Base. They have the same base, then the laws of indices state that if they have the same base, then and they are what? Multiplying. Do well to what? Add the superscript, or do well to what? Add the exponent, or the what? Powers. Alright, so here since they don't have what? The same base, different bases altogether. A and B, they are different. So since they don't have the same base, then I don't add any exponents to them. So I have a to the power 4, then b to the power 4. As simple as that. Alright. Please do you understand this? Sure. Alright, let's see something here. You'll be applying this one here. Alright. Now, a squared, b squared. Somebody can write it as a squared, or we can write it as a squared, b squared times a squared, b squared. Why? Now, if I have 2 to the power 3, 2 to the power 3 means what? 2 times 2 times 2. Right? 2 to the power 3 means 2 times 2 times 2. Because 2 is multiplying itself how many times? 3 consecutive times. Right? 2 to the power 10. 2 times 2 times 2 times 2 times. Up to the 10th term, right? Sharp. So a squared b squared times a squared b squared. So it means that this a squared b squared will multiply itself with 2 consecutive times. So now we have that a squared then a squared. They are brothers, right? So I have a squared times a squared. Mind you, the operational sign here is what? Multiplication. Then here times b squared times b squared. So a squared times a squared. Here they have what? The same base, and they are what? Multiplying. So what do? You add what? The exponent. So I have a squared plus 2. So a to the power 2 plus 2. So I'll be adding this superscript. So 2 plus 2. Then times b to the power 2 plus 2. They have the same base and they are multiplying. So what do we do? We will add what? The superscript. So I have a to the power 4 times b to the power 4. So a to the power 4 times b to the power 4. We also get to a to the power 4, b to the power 4. So it's the same thing. So in mathematics we have different diverse what? Ways. So if and only if you solve it properly, you can use different or any method in solving that. If and only if you solve it properly, you get what? The same results or the same what? Answers. Alright, so let's come back to our lovely question here. Now, we want to make L the subject. See where what L is. Look at the place L is. The position of L. Very, very dangerous. How will you get to this L? It's very, very simple. If you listen to the instructions, it's very, very simple. See the position of L. Alright, so now let's go. We have square root. It involves square root. So how will we do it? Then, if it involves square root, then it states that what? have to what? Square what? Both sides. That's what I taught you, right? You have to square both sides. You have to square both sides. So this one is method 1. Method 1 is solving that. Method 1. So we are squaring what? Both sides. So you square both sides. Square both sides of the equation, right? So you square both sides. So it means that G all squared equals 2 pi then the square root of L on G all what? Squared. So it brings us to what? A squared B squared all squared. Right. So now I have this. So I told you that what? They are what? They are multiplying 2 pi times square root of L on what? G. They are multiplying. So it means that this square is affecting what? 2 pi. It's affecting 2 pi. And also affecting what? This square root of what? L on what? G. So it means that G squared will be equal to what? 2 pi all squared. Then times square root of L on G all squared. Please, are you following? So now this square root takes that, right? So now I have what? G squared equals 2 pi all squared. It means 2 is multiplying what? Pi or what? Squared. So it means that this 2 will affect this 2 here, and this 2 affects pi. So I'll get 2 squared times pi all squared. Then times, now the square root is gone. So I have L on G. So G squared equals 2 squared gives 4. Then times pi squared, then times L on G. Very, very simple. Very, 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 very simple. Very, very simple. Very simple. So G squared equals 4 times pi squared times L on G. So now G squared will be equal to 4 pi squared L on G. So G squared equals 4 pi squared L on G. How many times here? We have 2 what? Tens. What's the LCM? The LCM, sorry. It's A. Then here is A. Then here is also what? A. Sorry. So A. Then here is what? G. So what do? You have to what? Take the LCM, right? Of both sides. The LCM is what? G. So you have to take what? The LCM of what? Both sides. So now G squared times what? G equals 4 pi squared L on G times what? G, right? It's A, sorry. So here is A. So now A. So G squared times A equals 4 pi squared L on what? A times G. So G squared times A gives what? In alphabetical order. It gives AG squared equals, now A cancels what? A. So I have what? 4 pi squared L. 4 pi squared L. 4 pi squared what? L. So now, what do? I want this L. Now, this is how far the Lord has what? Brought us. So now I want L. So what do? Now 4 pi squared is multiplying itself towards L. That's the reason why they are what? Together. So what do? We have to separate them. So AG squared all on what? 4 pi squared equals 4 pi squared L all on what? 4 pi what? Squared. So this one cancels that. Right. So I have what? L equals AG squared all on 4 pi what? Squared. L equals AG squared all on what? 4 pi squared. So therefore, this is how to make what? L the subject using method what? 1. Using method 1. So it's very, very simple. Please watch the tutorials very, very well. You understand it. So let's move on. Let's see the method 2. Method 2 in solving this. Method 2. Method 2 in solving this. Now this time around, we won't square with both sides. We won't square both sides. But we will rather divide both sides by what? 2 pi. Divide both sides by 2 pi. Why am I saying this? 2 pi is multiplying itself to the square root of what? L on G. So we can what? Divide both sides by 2 pi. So now G on 2 pi equals 2 pi square root of what? L on G all on what? 2 pi. So this one takes that away. So I have what? G on 2 pi equals square root of L on G. So now, what do we do here? We have to what? Square what? Both sides of the what? Equation to remove what? The square root. So now, G on 2 pi equals square root of L on G. So now square here, then now square there. So this square cancels that. Now, G on 2 pi, or what? Squared, equals L on what? G. So I have G on 2 pi, all squared, equals L on G. Very, very, very simple. So how will we continue? Now, watch here. If you have 2 on 3 all squared, 2 on 3 all squared, these two affect the 2 here, and these two also affect what? 3. So as that, these two affect 2, then 2 affect what? 3. So I have 2 to the power what? 2, all on what? 3 to the power what? 2. So 2 to the power 2 gives what? 2 times 2, all on 3 to the power 2 gives what? 3 times 3. So 2 times 2, 4, all on 3 times 3, 9. So 4 on 9. 4 on 9. So this is how we can do that. That's how we can do that. 4 on 9. So if I have G on 2 pi all squared, how will we solve that? So from this understanding, the example here, we can do that. So these two affect what? G, and also affect what? The whole of 2 pi. So I have G squared all on 2 pi, all what? Squared, equals L on G. Right? Very, very simple. So now G squared all on 2 pi all squared. Now 2 pi all squared, we said that what? 2 pi all squared. You can do it as what? 2 pi times what? 2 pi, which is 2 times 2. 2 times 2. Then what? Pi times pi. 2 times 2 gives what? 4. Then times pi times pi. That's what? They have the same base and they are what? Multiplying. So what do you do to the exponent? You add. This one is exponent 1, exponent 1. So 1 plus 1 gives 2. So pi 2. So I have 4 times pi squared, which is 4 pi squared. 4 pi squared. So now, as that, so I have G squared all on 4 pi squared equals L on G. So this one is A. Sorry. So A, and I have A. So still A. Sorry. A. It's A. So G squared all on what? 4 pi squared equals what? L on A. So what do we do? Now, fraction, they involve what? Equal sign, right? I just cross multiply. So I have A squared, that's A times what? G squared equals L times 4 pi squared. We want L here. We all can see that what? They are multiplying. So if you want L, what do? You have to divide both sides by what? this 4 pi squared. So I have a times g squared all on 4 pi squared equals L times 4 pi squared all on 4 pi squared. So this one cancels that. So therefore L will be equal to what? A times g squared gives what? A g squared all on 4 pi squared. So that's that. That's that. Very, very simple. Very, very simple. Please adhere to what I'm saying. Listen to instructions in mathematics. The rules and regulations governing mathematics, the laws, they are very, very important. So you listen to them, you'll be very, very good in mathematics. Don't fear maths, get the thing. You'll be an excellent student. Alright, so watch the solution. Alright, so now let's move on to example 3. Example 3. Example 3. Example 3, then we proceed. So we have to make R the subject. We have to make R the subject here. Now, when you check this equation, on our right hand side, we have what? Two expressions. Because this addition sign is separating what? This k from m on r squared. Then here we have what? 1 term. So in all we have what? 3 what? Terms. So 2 terms here, then 1 term. So 3 terms. Now, you ask yourself, what's the LCM? Because here it involves what? Fraction. So we have to multiply by what? Each term by the LCM so that the denominator goes off. So LCM equals what? R squared. Why is it R squared? This one is divided by 1, here also by 1, right? So 1 times R squared times 1. It's the same thing as what? R squared. Okay, so P times R squared, I'm multiplying each term by R squared, equals R squared times M on R squared, then plus R squared times K. So R squared cancels R squared. So P times R squared, I get P R squared equals M plus R squared times K. I have R squared K. So we are making R the subject. R the subject. So now, what do we do? If we are making R the subject, what do we do? Then, here we have what? R or R squared here. Then here also we have what? R squared. Then what do we do? On our last video, we said that when we have R squared here, then the same thing R squared here. What do? We group them what? Aside. Group them at one place. Then we do what? Justice to them. Alright, so PR squared minus R squared K equals what? M. So what do we do here? We have to factorize R squared what? Out. You have to factorize R squared out. So R squared out, then I have what? P, then minus what? K equals M. Now I told that factorization is the reverse of what? Expansion. So R squared P minus K, that's the expression, equals M. So what do we do? Now since R squared is multiplying itself to this, the whole of this expression, P minus K, we have to divide both sides by what? P minus what? K. So r squared, then p minus k. So here p minus k, then equals m all on p minus what? K. So this one cancels that, right? So I have r squared being equal to m on p minus what? K. Now, you want to make r the subject. Now, you've gotten access to what? R squared. But now, the question says make r the subject. So now, you have square here, right? Not square root. You have square. So you have to what? Introduce what? Square root. When you have square root, you introduce square. But when you have square, you introduce what? Square root. Alright, so I'll take the square root of what? Both sides of the equation. So square root of r squared equals what? Square root of what? M all on what? P minus what? K. Square root of r squared equals square root of m all on p minus k. So this one cancels that. So I have r being equal to square root of m minus what? P minus k. So square root of m all on what? P minus what? K. I told you on our, let's say, last 2 videos or last 3 videos that when square root is coming, it brings what? Plus or what? Minus. So when they ask you square root of 4 is what? Plus or minus what? 2. Why is it so? Now watch it. Square root of 4. Square root of 4. We all know that square root of 4 means 2 times 2, which gives what? 4. Now they are what? The positive numbers, right? Now let's recall negative numbers. Negative 2 times negative 2 will give what? 4, right? So it means that square root of 4 is what? Either plus or what? Minus what? 2. Square root of 4 will be what? Either what? Plus or minus what? 2. So minus 2 or positive 2, they will all give us what? Square root of what? 4. They will all give us what? 4, sorry. They will all give us 4. So square root of 4 is what? Plus or minus what? 2. That's minus 2 or what? Positive what? 2. Square root of 4 is what? Plus or minus 2. Minus 2 or positive 2. When you have square root of 9, plus or minus 3. Because 3 times 3, that's positive 3 times positive 3, you get 9, positive 9. Then negative 3 times negative 3, you also get what? Positive 9. Because negative times negative gives what? Positive. Positive times positive gives what? Positive. So integers, the symbol z, integers, they are what? The set of what? Negative natural numbers and positive natural numbers, including what? 0. The set of what? Positive natural numbers and negative natural numbers, including 0. So it means that 0 is an integer, don't forget. So they are what? Square root. So please, when square root is coming, it brings what? Plus or minus. So please don't forget, it brings plus or minus. Let's solve our last example, then I give you questions to try. Give you questions to try. Please do all to subscribe to my YouTube channel so that whenever I post a video, you'll be the first to receive it. Massa tutorials. It will help you and help your friends. So please alert your friends to what? To subscribe to my channel. Like and share the videos. Alright. Alright, so let's see. C equals B squared plus 4 all on AR. So now here we have 2 terms here, right? 1 then 2 terms. because b squared plus 4 is an expression at the numerator, right? Then AR is the divisor for this b squared and also what? 4. So they are together as what? 1. I told that if you want to simplify this, it moves further as what? B squared all on what? AR, then plus 4 on what? AR. That's it. If you want to simplify further, b squared on what? AR plus what? 4 on what? AR. So it's the same thing. Alright, so here, this one, the divisor is what? 1. 1 times what gives C is the same thing as what? C. So the divisor is 1. Now here, we are making B the subject. B the subject of this relation, this wonderful relation here. Make B the subject. Now we can what? We can cross multiply. We can cross multiply immediately here. So I have C on 1 equals b squared plus 4 all on AR. So you can cross multiply. So C times AR equals 1 is multiplying this expression b squared plus what? 4. It gives us the same result. That's b squared plus 4. Right. So now C times AR gives C AR car in alphabetical order. In alphabetical order. ACR equals b squared plus 4. Now we want what? B. And now 4 is adding itself to what? B squared. So what do? Do we divide or do we multiply? We don't have to what? Divide, but rather we have to send this positive 4 to the what? To the left hand side, so that it subtracts itself from what? The expression AC what? R. So I have ACR minus 4 equals what? B squared. So we've what? Transposed this positive 4 to what? Negative what? 4. So proceed as b squared equals ACR minus what? 4. Don't forget that ACR minus 4 is the same thing as minus 4 plus ACR, because this one is positive and this one is negative. So you can write it as that. It's the same thing. Don't be confused. So now, what do? We have b squared equals ACR minus 4. We have to take the square root of what? Both sides to what? Cancel the square. I told you that when you see square, you introduce what? Square root. When you see square root, you introduce what? Square. When you see cube root, you introduce what? Cube. Do you understand that? So don't forget. So square root of b squared equals square root of ACR minus 4. So this one cancels. I have what? B equals square root of what? ACR minus 4. It brings what? Plus or minus. Plus or minus. So that's the what? The answer for making B what? The subject, or for making B to stand on its own. So now, let me give you quick assignments to do so that we will end here. Our next video will be solving questions. So we are done with change of subject. Our next video will be what? Solving questions on change of what? Subject. Solving more questions on change of subject. So that we'll be equipped, we'll be grounded in what? Change of subject. We'll get the better foundation in change of subject on this topic. So assignments. here, we are to make be the subject. If I circle a variable, it means we are to make that variable circle the subject. So now I've circled the variable b. So we are to what? Make b the subject of this relation. We are to make b the subject here. To make b the subject. Then I have m equals 3 pi all on square root of x on k. So we are to make k the subject. We are to make k the subject. We are to make k the subject of this relation. So we have 3 questions. Try them, please. If you want any further inquiries, kindly call me 05410864489 or drop it at the comment section. Alright, please do all to subscribe to my YouTube channel so that whenever I post any video, you'll be the first to receive it. Massa Tutorials is there for you. Assignment. So question 1, question 2, question 3. Alright, have a nice day. Take good care of yourself.